All right, live from beautiful downtown Southern Maryland, it's time for Gears of Resistance episode number 12 for July 25th, 2015. We are a bi-weekly podcast dedicated to bringing you the latest and the greatest in the open source hardware world and how to run a business based on open source and all the cool tips and tricks to do your DIY electronics project. All right, so it's been a few weeks because it's summertime and we are really bad at keeping up on a schedule because we don't have a schedule really during the summertime. It's a free for all. Let's go ahead and get into some of the stories. Do you want to do the stories first, or shall we do some of the product stuff first? Let's do some product stuff first. So one of the cool things I just recently acquired and has been very useful has been a new set of helping hands. It's like Doc Ock from Spider-Man. So pretty cool. These are very flexible, very bendable, with little they got a little silicone rubber tipped on the gator clips so it doesn't bite into your board too bad. But I really like this one coming from the old, the old helping hands with little, well, it used to have a little binocular or some sort of lens, magnifying glass. And this is well and good, but you were limited in your degrees of freedom, I guess. So this guy, which I purchased from Adafruit, pretty cool. It's got a nice tough base, place to put some parts, and then you can expand and move the arms around as you see fit. And I've been using it a lot, especially for soldering projects. It's real nice to get the project just at the right angle, and you can solder away a lot easier. So that's been pretty cool. I really like that. What else? Oh, the other cool thing. So on the hardware side, electronics side, I think I mentioned I was getting one, but I don't think since last time I played with it, but the Photon from Particle.io. It's it's sort of like a Arduino. It's got its own programming environment, and it has its own set of special libraries. But in terms of complexity, it's no more than an Arduino programming. But the cool thing of it is it's the Wi-Fi built in is really robust. So I've been playing around with the SB8266, using it off of like a standard Arduino. But I really like the Photon because the power of the library, it's all written with I guess JavaScript or Node.js, which is, as a hardware guy, I'm more and more becoming, I realize I have to become a web developer too to do anything useful anymore, which is cool. But so with this guy here, I was able to take their kind of like their intro code, their hello world kind of stuff, and basically from a browser, run a little Node.js script to launch a server that serves a single HTML page that has some JavaScript and some basically I can take a reading and put a little photo resistor on here, so I can read the analog input and tell me how bright this guy, how much light this guy's seeing. I can also have it set up to where I send it just sends an alert. So I set a trigger value, say like 1,000. If it's below that, it's dark. If it's brighter than that, if it's larger than that, it's bright. And it automatically updates a little field on a web page with that data, so it's real time. And then there's a little LED on here, and there's a little radio buttons on my website, and you just hit start, turn LED on, turn LED off. And like I said, it's surprisingly simple. how little code that you need to write, because again, all the stuff they've done on the back end with the Photon, really powerful and really quick to turn around products, I think. So I'm actually working on one right now, and it's going in almost too smooth. Like, it's like, what am I missing? Especially because, it's one thing to do the electronics. Unfortunately, for better for worse, the electronics is simple enough and commoditized enough where the real value now is again, creating this website, these web services, kind of quote unquote Internet of Things. That's be able to interact with your hardware over the web simply. I haven't found anything better yet. So Photon, it's from a group called Particle.io. I think they used to be called Spark. And the Photon is $20. There's also a 3G version. I haven't checked out what the pricing is on, what kind of deals they've worked out for the data plan. But if you need to take the next step and you don't even have Wi-Fi around, they do have a 3G model, which same simplicity, just different hardware. And I'll throw up some links to the code. Let me see if I can share it real quick. So is that it? Yeah. Well, that's another project we're going to talk about. So here's their website. Again, this is the one I'm using here, the Photon. This is the 3G model. They call that one the Electron. And if you wanted to, if you were so desired, this is the development board. But if you wanted just their chip, you can buy just the chip too. They call that the Spark Core. So you can include that into your own hardware if you want it, which is pretty nice. And the price, I mean, I remember probably just 4 or 5 years ago looking for, like, I think it was like Blue Smurf Bluetooth, like just trying to get this really crappy little board that didn't have any header pins, and it was the really tiny header pins, the pitch of the pins. And I remember it was like 40, 50, 60 bucks to get that. And, it was just the Bluetooth part, and then you had to write all your code from scratch. So today, here we are, just a few short years later, and these products are out. For someone who's a system developer, system integrator at that level where I'm at, versus, doing the quote unquote hardcore electronics, this stuff saves a lot of time, and it's awesome. So let's what else? Node.js. So yeah, if you want to take advantage of making the web services for the Photon, go over to Node.js, download their packages and whatever operating system you're running, and yeah, get started. I'll admit I am not a code guy, but I've even found it to be easy enough to, again, I can set up a local website, a local web page, local host port, like 8080 or whatever, and I can then go sit on my tablet in the bedroom and control my Photon, which could be in another spot. So you could have your your laptop running the server in one room, your Photon is in another room, and then you can be checking on it in yet a third room. It's pretty cool. And so I do have, let me see here. Boom, 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 boom. I did put up a link to it on my Hackster page. We talked about Hackster.io. We actually got another one to talk about today. There's like the competition one for social maker websites now. Where's my projects at? My projects, here we go. Part of my French. It's Sunday. Okay, where are my projects? All right, maybe I won't be showing you my projects. Where's my profile? Did I put it on Hackster? I'm pretty sure I did. Or maybe I put it on Makerspace. Oh, okay. So I'll have to move it over there. So let's just go ahead and jump into our next story then. So last week we talked about Hackster.io, which is like a project sharing website for the maker community. Finally got invited into the beta for Makerspace, which is the quote unquote official community of Maker Faire. So this is, you know, Make Media and I guess O'Reilly backed social media site. And I've been playing with it a little bit, and it's pretty comparable to Hackster.io. I think, you know, we'll probably be cross-posting on both until we figure out, you know, who's going to be the quote-unquote winner. But so yeah, over there it's makerspace.com, and I'll put the link to my particular profile up in the notes. But the one thing I don't like with either one of these right now is that it's pretty not robust. It's pretty basic project pages. I'd like to see a little bit more like Instructables like interface. But it's, you know, these are both new, so we'll give them the benefit of the doubt, and time will go on. So nothing really on there, just a link to share it, and then of course all the code and I did a little fritzing schematic that's all over on GitHub. So I'll actually go ahead and click for people that are watching. I'll click on the. You'll notice that the file extension for the firmware that goes in the Photon is .ino, just like Arduino. There is, again, it's basically, there's a Spark library that if you use this library, it handles a lot of the backend HTML, HTTP, IP, TCP, IP, whatever else magic software networking stuff. Again, I am not a guru when it comes to the software world. I'm a hardware guy, so I was even able to make this stuff work, and I did it in pretty much, you know, there wasn't really any debugging or troubleshooting. It pretty much worked. So, like I said, you'll notice it's pretty much Arduino-like code. Again, the Spark libraries to allow you to have that web functionality are a little bit different. You know, if you have played with libraries, and you know, especially buy stuff from Spark Fun or Adafruit, where you download the library and, you know, you would type in, like, you know, again, Spark, you know, you declare a type of a Photon, and then you would do Spark dot function or Spark dot variable, which is, again, some of their internal functions. If you're used to that kind of concept of, you know, declaring an object and then the dot whatever function or function you want to use, you should have no problems using the Photon. All right, so what else do we have to talk about? Oh, SatNOGS. So this is a project that I've been following on and off, and I think I'm finally going to commit to trying to see if I can get my local makerspace and my local ham community to come together and maybe build one of these. I was listening to a podcast recently, and I apologize, I think it was Floss Weekly, but I could be wrong, that talked about SatNOGS, and that kind of was what reinvigorated my interest. Also, one of the founding members of it said that hardware-wise, it's only about $400 to put together a ground station. So I thought, wow, that is very doable, especially if you look at the makerspace. If you can get, you know, 4, 5, 6 guys to pitch in, you know, it's, you know, $50 each, maybe less, and you can have a ground station to talk to satellites. That's pretty cool. And then also for us, I'm trying to see if we can get more people to join our makerspace through the ham community. So I think this is a pretty cool marriage. If you don't know what SatNOGS is, it's a satellite network open ground station. So the idea is they want to blanket. It's all open source. They want people to go download their software and their hardware files, make these ground control stations. Basically, they look like Yagi antennas. And there's, you know, a rotator to help rotate it. And then you hook this up to a computer that connects to the internet, and you can now become part of the SatNOGS network. and then people can say, hey, I want to listen to a satellite that's in whatever type of orbit, and SatNOGS would compute which nodes it would you need to be on line to listen to it, and how to turn the rotator and what directions. And people can request time basically on your ground control station. So it's cool because yes, you could be listening yourself, but you actually kind of give up control once you've built this node and you've put it onto the network. Other people can request you, so it's a whole gambit. It's the whole like technology stack. It's open source electronics and hardware. It's radio design, antenna design. It is open source software that runs it, both the firmware on board, the stuff that runs on your computer, and then the fact that it connects to this back-end network, web-based Internet of Things, and people can log in and again listen on to your antenna anywhere around the world is pretty cool. So if you're interested in radio, ham radio, open hardware, and you're looking for a project, like I said, this is probably going to be my next new project. And it's, I mean, like literally everything, like even like the tripod, they have the 3D files for the mounts so that you can go ahead and 3D print the non-metallic parts. And then there's the I'm curious what they're using for their I'm assuming they're probably using KiCad for their circuit capture stuff. But it's all there, and I'll put the link up if you're interested. What else do we got? What else? Oh, the HC05. I was going to talk about with the Photon. Like, I'm sure by now everyone knows about it, but if you're so the Photon does Wi-Fi. If you want something that's more of a Bluetooth project, the little HC05 Bluetooth module. I ordered from some to do a workshop at our makerspace. Unfortunately, they haven't come in on time. But just if you haven't heard and you want to do Bluetooth work, the HC05, as far as I can tell, is still kind of the king. What else? Oh, I found a new app, Blynk, B-L-Y-N-K. It's an app for your next Arduino, and they also say Raspberry Pi project. I haven't played with it yet, but the thing I like about it is the idea is, again, I'm a hardware guy, and writing firmware is one thing. Writing even web HTML stuff is another. But when it comes to doing freaking apps for smartphones and Apple phones and Yahoo phones and Android phones, I have not got there yet. So Blynk comes in. It's an app that lets you basically create another app inside of it by basically dropping widgets around. So I think I talked about one. If I haven't, I think it's because it's for a Mouser project I'm doing. So when that comes out, I'll talk about it more. This one, as far as I know, is free because I did download it and I don't recall playing anything. And basically, you can drag things like, output and input representations of like push buttons, slider bars, toggle switches, and then little bar graphs and little circle graphs and little looks like little joysticks, like D-pad and rotator joysticks like you would find on your game controllers. Basically, this app then takes all that data, all those inputs, and packages them up and sends them. And I think it says over the internet, so I'm assuming it's over Wi-Fi. And then same thing like the Photon, you'll have a package that listens to these things coming off your Blynk app, and you can create on the fly an app to control your Arduino-like thing. Now the next cool thing would be then when you're like after you've done your widgets and you've got all your widgets placed, that you could like go up there and hit file export, and it would generate its own app that you could install and put up on the marketplace, the app stores. That would be really cool. So that's just me asking, please, nicely. When I get around to actually playing with Blynk, I'll give a more thorough review, but it was so cool to see that I had to we had to get it out there. So the other thing I don't know is like it says it was kickstarted, which means people donate it, but is it now free? Like, is the whole thing free? So a lot more questions, but I wanted to share this. All right, what else? Oh, Common Parts Library. I think I talked about this last week or the other week. There is download symbols and floor prints. It's SnapEDA. It looks like, and someone out there who knows better, correct me if I'm wrong. It looks like each part, you can't like just download like this is a library. It looks like you download each individual part, and I guess you can make it into, you could create like a custom library in Eagle. But is there a way to, does anyone know? Is there a way to just grab every part, you know, and is it like is there a GitHub page or whatever for all the symbols and footprints for the Octopart Common Part Library? I've been really liking it because, again, you know, yeah, there's like, you know, you go into any of these parts distributors and you type in resistor and you're like, there's 15,875,958,000,000 choices. And you're like, oh boy. So this Common Part Library that helps whittle it down to like, okay, you know, like here is the things that most people are using, or the ones that are most widely available. Thus, again, most people are using. That really helps cut down on your building your bomb. So check that out. So Octopart in conjunction with SnapEDA. Boom, boom, boom. I hope I've been presenting to everyone. If not, I screwed up. What else? What else? Let me. So this past week, this weekend, I've been working on. Ooh, that went dark. That went bright. We want to find the happy middle. Yeah, it looks decent. I didn't fire the lights up. I should have done that. Anyway, so it's pretty underwhelming. You can kind of make out the traces on there. Maybe if I... Yeah. So what this represents is the first attempt at milling a PCB from scratch. So basically going into Eagle, creating a little circuit, exporting that as a SVG file, loading that up into a CNC machine software, and having it route out the traces. And then using a convection oven to reflow some solder and the Reflowster to control that, and to create basically just a little 2 LED circuit. And after some cajoling with it, I got it to work. So it's my first milled PCB. I've never milled a PCB before. Usually just you get them made and then you solder them as yourself. Which usually, you know, back in the day, I used to etch. That kind of, it just gets nasty. And today with things like Octopart, it's just so much cheaper to just do a board and go get it made. But sometimes, every now and then, you want to, even Octopart, you know, it's a week or two. You can get it around a week or two turnaround. Even that can be too long, especially for certain board types. So with the x-carve here, let me... Boom, 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 boom. Let's share this. So this little guy here is great for doing PCBs. I mean, that's basically a foot-by-foot work area, which I don't think anyone's going to be doing circuit boards bigger than a foot-by-foot. Usually I'm working down here in like the 2 by 3 inches kind of thing. Maybe 4 by 6 is like the biggest guy. So anyway, and I'm a little torn right now. They have what's called Easel. Let's go up here and fire up Easel. which is a web-based CNC controlling software. You can use things, other ones, G-Code Sender. Let's try this guy here. But this is specifically tailored for their hardware. And I think the other day, I'm not sure if it was my internet was slow or hello, there we go. They were having website issues, but the problem with something in the browser is if the internet's not connected, you're kind of SOL. And so, it would be nice if they could, I'm not sure what is running this software, but if there could be an offline version. Anyway, so this is the new board we're working on. Again, did the design in Eagle, export it in SVG. I'm actually going to do a whole write-up on the lessons I've learned. Like they have a tutorial on doing PCBs on the Inventables website. I found some, at least maybe I didn't build my x-carve is not built 100% correctly. Maybe it's working, but some of the things they recommend in terms of settings in like the depth of the cut and the speed didn't work for me. I went through about probably 10 boards that were either too deep or it didn't cut correctly, didn't carve out correctly. So I've been tracking my lessons learned, and I'm going to write up probably do a video on the whole workflow. But so the idea, just real quick, the board is that there's going to be, I think these are the LEDs. It doesn't really matter. Ground. So yeah, so the LEDs will be here, little resistors, little screw terminal. You plug in your 3 volts, 5 volts, and ground, and these are just going to be little buttons. So you press your finger, you connect the circuit, and the LED will light up. It's just an idea of, it's basically proof of concept. Can we mill PCBs? And then they're going to be building a couple of simple things just to teach kids some electronic stuff. So that's the idea. But like I said, it worked pretty well. There's EagleCAD for those so interested. I'm using version 7.2. Some of the export to SVG file or user was it UPL user library? Basically, you can create custom like macros. Their export to SVG, the latest one I can find, is having some issues with the traces. In 7.2, it seems like some of it worked for 6.0, like Eagle, whatever. If you have a 6 dot whatever version of Eagle, it'll work better. That's just been my experience. So I guess real quick, just to give everyone the whole tool chain. So EagleCAD designed the file, export to SVG, import that into here, get it all lined up. And again, I'm going to do a really thorough write-up on every little step, every little issue I found. Get some solder paste, put it up on the board, throw your components on there. I found this guy, Reflowster. Basically, it controls your convection oven. So basically, it works through the heating cycles. So I guess when you resolder, there's like a preheat. Then there's the to the board up to speed. So I guess there's like no thermal shock. Then there's the high heat that actually makes the solder reflow, and then it kind of cools it back down. This guy, it's kind of like set it and forget it. Just get a really dumb convection oven, nothing digital, just pure analog. Set it to the highest settings. Plug this in between the power wall and your convection oven, and it controls turning the convection on and off at the right temperatures and at the precise times to do a really good job on reflowing. And then that you'll get the little board like I showed you. So you're not going to do fancy boards. You're not going to do stuff with really tiny pitch parts. I'm using like 12. What's the package types? Is like 1210, 1206 resistors. I tried 0805s on this demo board, and I think it was too small. So I bumped up to the next larger size, and hopefully, fingers crossed, that will work a lot better. Boom, 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 and yeah, that's it. And then reflow it, and boom, you've got a board, a prototype at least. Oh, so one thing else I want to leave you with. Let's see here. I've already showed you that. I found this store on eBay. It's Chavazu. It's a group out of China. It is basically really, really dirt cheap. Sensors, motor stuff, controllers for your electronics, for your Arduino projects. I mean, like here's a water level sensor for Arduino, $127 with free shipping. I don't know how they do it. I mean, granted, the parts that are on there are, it's probably less than a quarter. So yeah, $127 is still 400% markup. And then they can eat the cost of the shipping out of there. But I mean, it's everything: signal generator modules, ammeters, sensors, potentiometer models, accelerator modules, accelerometer. Here it is. 3-axis output accelerometer module for Arduino, $160, $188 free shipping. So I picked up a couple parts just to see, like, is this just this is just their failed components. Like, okay, we know what to do. We'll take the parts that failed any sort of QA QC and just sell them, and people just buy them, I guess, for aesthetic purposes. But no, that's not the case. I've hooked up 2 of my sensors so far, and as best as I can tell, it's getting me the readings that I would expect. So the flip side, of course, is you're going to wait for me, it was about a 2-week turnaround time to get it shipped from China, which is actually better than even just a few years ago. It was a solid month to get anything over here. I don't know if they've worked out some deals with either the imports or maybe they're now like, they don't sit so long in an export over there. I don't know. But for $1, some of these parts are like $1, which if you try to order them here stateside, you're probably you're gonna pay $10 for the part, and then you're still gonna pay $5-6 for shipping. So if you can afford to wait a few weeks, this eBay store seems pretty good. But for the times you can't wait, and you need to get stuff here quickly, or there is always, let's be honest, there's a risk in ordering things from China. You're not always guaranteed necessarily to get what you think you're getting, or it's potential you're going to get busted stuff. But so when you need to do something, when you need reliable parts, when you need to no crap, I really need to make sure I'm getting 10 of these parts, and I need it in a couple days. Everyone knows full disclosure, I write articles for Mauser Electronics occasionally. I'm not employed by them, but they just teamed up with Adafruit, and they're now a distributor of Adafruit products. So I'd like to support both, because while Adafruit is good at really good at building the stuff, sometimes the shipping can be a little expensive, and or depending on where you live, it takes a little bit longer. Mauser, again, because of the economies of scale, you know, when I order stuff from Mouser, it's guaranteed. You know, if I select, you know, UPS 2-day ground select, it's going to be here exactly when I think it will be. And at least from what I can tell, you know, I've been buying lots of parts. They obviously have some sort of deal with their UPS and the FedExes of the world, because, you know, price per part, the shipping is usually really fair compared to, like, you know, smaller companies that are, you know, they don't have the economy of scale, so they can't negotiate better rates. So anyway, that's not an endorsement. That's just my personal observation. So it's cool though that now Adafruit is, you know, they're big enough of a player in the world of electronics that, you know, the Mausers of the world and whatnot are holding and shipping their parts for you. So yeah, I'm gonna stop sounding like a fanboy of both of them. And I think that does it for this week. Actually, I think that was the last story. So let's just go through the notes here. Boom, 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 boom. Yeah, that's it. So we're back. Hopefully, probably not though. Probably not at all. Between, you know, we're going in towards the kind of the middle end of summer, so, you know, places to go, people to see, vacations to take before we go back to school. So bear with us, but by September we'll be back on the more bi-weekly basis, because we'll be settled more. So with that, head over to gearsofresistance.com, share your comments, notes, thoughts, ideas, things you'd like to talk about. There's links to everything else that we do, don't do, and I guess there wouldn't be links to things we don't do. Yeah. But yeah. Also, join us, find us on Hackstry.io, makerspace.com. I'll put my links up there. And collaborate and share, and let's work on some things together and make some things. With this newfound ability to make PCBs, what I am planning on doing is, so if you've been around the electronics world for any time, you know Forrest Mims. Forrest M. Mims III, to be exact. He did a great series of engineer notebooks. Yeah, engineer notebooks that I think are exclusively through Radio Shack. I could be wrong, but the nice thing about his stuff, let's pick this one here. He's a very practical guy, very practical engineer. So a lot of his sensors, circuits, you know, there's not a crap ton of you know, tiny surface mount parts or whiz bang, you know, microcontrollers. He's doing really cool basic, not basic, I mean, they work and they work well. You know, so here's like a better voice transmitter circuit, which is definitely not going to show up because it is way too white. Yeah. Anyway, we'll share the links. So the idea is his circuits, because there are a lot of through-hole components, very large components, I think are really, really ripe to be breakout boarded, bobbed, B-O-B-B-E-D. So my thinking is that I can make boards. We're going to do take his circuits that are in his books, and what I would like to do is do two boards, like a board so that you could interface to like an Arduino Micro or a Photon, real tiny one, and then you would take his circuits and kind of like with a pair of female headers or whatever, you can do breakout boards. So if you wanted to test out, you know, one of his science and communication projects, you could do it relatively easily. And I think, you know, because again, a lot of his stuff was, you know, it's pure analog. You know, and it's resistors, it's transistors. There's nothing really a lot of, you know, no, I can't, I don't think I've ever seen any microcontrollers kind of stuff. But you take these basic, you know, circuits for sensors, you merge it with this, you know, Arduino, Raspberry Pi, BeagleBone, Photon world that we live in now. And I think you can see some really cool things to happen. So that's the plan, at least. That's what we're thinking about doing here. Yeah. So that's, I have definitely tried to prevent closing out this episode really good. So I guess I'll be quiet now. So thanks very much for listening and watching and clicking things and visiting stuff that we do elsewhere on the web. We appreciate it. And we're going to follow up here. We're actually probably going to today, here's a sneak peek, we're going to do probably another episode of Steam Power Podcast to catch up. So if you stick around for a little bit, we'll have one of those episodes coming out here shortly too. And I guess really, insiders, there's gonna be a lot of space stories, because the past 2-3 weeks there's just been a metric crap ton of space stuff, and it's been pretty cool stuff. So we'll talk about that in the next episode of Steam Power Podcast. But now, for Gears of Resistance, thank you all very much for listening, and until next time, keep it quirky. Thanks for watching.